We now come to a stage where we have to define what we call the state of a system. This is required because in thermodynamics, anything we study will typically be of this type. We will have one system, let us call it our primary system or system A, and we will have another system, the secondary system or the environment, let us call it system B. Thermodynamics studies the interaction, that is the give and take or the transfer of energy between these systems. And because of this interaction, there is a change in system A, and there will also be some corresponding change in system B. We have to relate this change to the interaction, and for this we will have to not only quantify the interactions properly, but we will have to quantify the change in the behavior of a system. And to decide on this change, we say that we study and we observe the state of a system so that we can note and study the change in the state. An illustration, not necessarily thermodynamic, a simple illustration of an interaction is a financial interaction. I go to a stall, I want a piece of cake. So I ask the serviceman for a piece of cake, he gives me a piece of cake and I take out of my pocket the appropriate amount of money, cash, and give it to him. So there is a cash transaction from me to the serviceman, and there is a material transaction between the serviceman and me. So because of this, the state of me changes. Earlier maybe I had so much money with me, say 80 rupees. I gave him 10 rupees, so my money in my pocket is now 70 rupees. So there is a change in the state of myself in terms of the money in my pocket. How do I define the state of a system? Let us say this is our system. Could be anything, water in a bottle, gas in a cylinder. We do two things. To define the state of a system, we have to do first, make a list of relevant characteristics of a system. For example, if we consider the system to be gas in a cylinder, closed cylinder, so a closed system. And we may say that look, mass of the gas is one relevant characteristic, pressure of the gas P is another relevant characteristic, and the temperature of the gas is the third relevant characteristic. It need not be 3, it could be as small as 1, it could be as many as there is no upper limit. More complicated and more complex a system, we will have a large number of these characteristics. Thermodynamics does not directly restrict the number of characteristics or relevant characteristics that a system may have. Later on we will see what are the appropriate numbers. Okay. The word relevant is important, and it is only experience which tells us what is relevant or not. For example, if this is a rigid cylinder and if there are going to be no significant variations in temperature and pressure, we will say that the volume is unlikely to change, and hence volume may not be listed as a relevant characteristic in this particular case. So after making a list of relevant characteristics, second operation is to quantify them. By quantification we mean measure, or by hook or by crook somehow put a value on each of these relevant characteristics. For example, we may measure the mass of the gas at say 20 kilograms. We may measure the pressure using a pressure gauge connected to the cylinder at say 20 bar, and we may determine that the temperature is 14 degrees C, perhaps a cold winter day. So when we do this, when we have a list of relevant characteristics and the quantity or the numbers associated with them, we say that we have defined the state of our system, and our system is this gas in the cylinder, mass 20 kg, pressure 20 bar, temperature 14 degrees C. So we can say our system is gas, symbolism could be like this, mass 20 kg, pressure 20 bar, temperature 14 degrees C.